Hello, today we're going to continue talking about sequences of transformations. Ultimately, we want to be able to identify what the transformations were that occurred to the shape. And so this is just going to be like a video more to build understanding of the properties of each of the transformations that we've been working with as they pertain to rigid motions, and whether the identifying parts that would allow us to know which transformation occurred. So if you look at this, it says sequences of rigid motions. The vocabulary is rigid motion, rotation, reflection, orientation, and translation. And we'll look at the very first question here. It says, in the following picture, triangle ABC can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. Which basic rigid motion or sequence of rigid motions would map one triangle onto the other? And so if you're looking at this, we know through rigid motions that angles have to remain, or angles are preserved. So one thing I would notice is that angle B from the original triangle is just down here, C to C and A to A. And I would identify this as a reflection. With a line of reflection BC. Now again, you might be wondering why I was able to do this. Essentially, I can tell a few things, but probably the most important one is the way the letters are oriented now. So you can tell it is a reflection because the orientation of letters changes. And what I mean by that is if I were to look how A went to B, B goes to C, and C comes back to A. So A goes to B, B goes to C, and C goes back to A. I would notice that this is a counterclockwise order. And this is my pre-image. I then looked at A prime to B prime. I would notice that these are going somewhat in the opposite direction. So A prime to B prime to C prime back to A prime. Well, I would notice that this is going a clockwise direction. And this is big for me because it's the only transformation that actually reverses your orientation. And so that's a telling tale that you have reflection. You can see the line of reflection being BC. So there are a few details or hints, but that would be one of the biggest ones. Okay, in the following picture, all right, it says in the following picture, triangle ABC can be traced onto a transparency. The transparency would then be rotated. It doesn't say that in directions, but rotated onto A prime, B prime, C prime. Which rigid motion of sequences of rigid motions would map one triangle onto the other? So a lot of you are going to jump right away. You can see this as a rotation. With center of rotation at B. And you can tell this because B and B prime are the same. And that would be also a clue up above that you had a line of reflection because B prime and B were the same and C prime and C were the same. A few things that you can use to identify this as a rotation. You know that the orientation is the same. And so if I'm looking at this, A goes counterclockwise to B, which goes counterclockwise to C, which goes back to A. And also in the image, we kind of have A prime over here, but A prime goes counterclockwise to B prime, which goes counterclockwise to C, which goes back to A. So you might be wondering, well, could it potentially be a transformation? And what I do notice is that lines, there's no parallel. And so if there's no parallel lines, you know that you do not have a transformation. So by process of elimination, we know it is a rotation. But I want to bring us back to something we talked about earlier in the unit. And actually what you can do is two reflections. And you might be shocked by this, but you could have a line of reflection here that would flip. And then you just have to have the other line of reflection there and flip again. And so something that you want to write down is two reflections equal a rotation. So if I'm thinking about this as a sequence of rotation or transformations, I could have two reflections equaling one rotation with, and this is the thing you want to highlight, with the intersection of the two lines of reflection at B. And just as a reminder, B is the point of rotation. Okay. Something else you want to add to this, the angle of rotation is twice the angle between the lines of reflection. So rotations, that's somewhat unique about them is that the lines of reflections actually intersect, and that can act as your point of rotation. And so this could be a series of transformations, or it could be a single one. If we go on the back, which of in the following picture ABC is traced onto a transparency. As I'm looking at this, I'll notice that this is a reflection. And the one thing that I would notice is that the orientation of the letters is different. So your line of reflection would somewhere be in the middle of this. We do know that the line of reflection would be the perpendicular bisector of each of the pre-image and image. But sometimes a line of reflection is not easy to identify. And so again, one of the things that would tell me is the orientation of the letters. So it is a reflection with a line of reflection through B, and it is the perpendicular bisector to A prime and C prime segments. One of the indicators again is the orientation. So A goes to B, goes to C, goes back to A, and that's counterclockwise. But the primes, where I go A to B, B to C, C to A again, that's clockwise. So we're just setting you guys up so that you can identify which kind of transformation you have, because ultimately what we're going to do in the following days is look at sequencing them, and not just like a rotation into a rotation, or a translation into a translation, or a reflection into a reflection. What we're going to do is we're going to combine them. And so in the following picture, we have two pairs of triangles. In each pair, triangle A, B, C can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. Which basic rigid motion or sequences of them would map one triangle onto the other? Well, if you're trying to go from A to A prime, B to B prime, I'm going to notice that these distances are not the same in direction nor distance. Okay, so that would tell me that it couldn't be a straight up transformation. I would notice that I didn't reflect over any line because the orientation is the same. And a point of rotation, kind of difficult to identify. So what you might want to do, and this is just one idea, there's going to be many sequences. But one idea would be to use the vector from A to A prime. So that direction and that distance. And once A was sitting on A prime, you'd kind of have a triangle that looks something like this. And then you could rotate it around until B matched up with B prime. Okay, so writing this out, translate A to A prime, then rotate at A till B maps to B prime. And so it's a combination of two things, a translation and a rotation, and eventually they'll line right up, which is kind of nice. And then again, this is just one of many different opportunities you have. And then scenario number two, somewhat similar, except what I'll notice is my orientation changed. So I would notice that from A to B goes one direction, but A to B and the other diagram goes the other direction. And so I do know that at some point I must have reflected, but I cannot see a way to make the perpendicular bisector that would all coincide. So that tells me something else must have happened. And so what you could do is you could translate B to B prime. So it's this vector. So we're going to go along this vector. And then after I have that vector, everything will be sort of lined up. As such. And then you can kind of see that I could reflect on top of each other. So I would reflect, then reflect over the perpendicular bisector to the pink A and A prime and the pink C and C prime. And so hopefully this gives you a general understanding of what can happen with the transformations. We're not stuck in just a single one. You can mix and match them. Understanding the order that you do them also will make a difference in the outcomes of your images. So take this moment to summarize what you've learned is more of a general understanding video than a concrete formula video. And thank you for your time.